Hey, everybody. Welcome back. This is Calculus 3, Vector Calculus at College of the Sequoias. We did projections in a previous video. I wanted to revisit that, show another way to think about it. One of the students asked for a way to memorize or know where the projection formula came from. Let's just take a look at it. We have a vector V. It's got a magnitude of V. We want to break it down into two components that are orthogonal together, orthogonal with each other. I'm using unit vectors E1 and E2. We want the vector of V in the component in the B direction, as well as a vector that's orthogonal to B. It may not be the same length as B, so it's some length A times that unit vector. And for the vertical one, I said C times E2. I initially wrote B there, but I have a B vector. I don't want to confuse it. We're going to do it that way. Looking at this triangle right here, it's a triangle, so let's look at the triangle. We can look at our trig values. X is r cosine theta. Y is r sine theta. If I did this as a circle, the radius is the magnitude of V, which means this X side is the magnitude of V cosine theta, and Y is the magnitude of V sine theta. So I'm plugging those in for A and C. Those are my multipliers on E1. E1 and E2 just give us directions. We need the magnitude in those directions. And it's the lengths of those sides of the triangles. Okay, so where do we go from here? Well, recall cosine theta is V dotted with B over the magnitude of V and magnitude of B. And also recall that finding E1 and E2, E1 in particular, we're going to do the magnitude of B, or B divided by its magnitude, will give us a unit vector in the direction of B. So let's take these and plug these into the left side. Cosine theta I'll do in red, e to the 1 I'll do in blue. So my V, magnitude of V comes down, my cosine theta comes down, B dotted with B over magnitude of V times magnitude of B. Notice the B's cancel. My e to the 1 comes down, I've got B over the magnitude of B after its substitutions. The V's cancel. I've got two magnitudes of B to multiply together. This gives us B squared on the bottom. And that's how we come up with projections. Projection of V onto B. We could use magnitude of V sine theta and do something similar with sine theta. We haven't talked about sine theta yet. Sine theta is 11.4. It's when we do the cross product. It will show up there, but that's more work than is necessary. If we know V and we know the projection of V onto B, we can just calculate C of E2 by subtraction. Subtract the projection over to the left side. We've got C of E2, which is the length of that vector, or that vector right there, is V minus the projection of V onto B. Now we've got both of our vectors, A times E1 and C times E2. That's it. Peace.